All right, we are finishing up the notes from 1.5. So when I drop an object, this is the formula that you will use. So h is the height at any given point in time. T is time in seconds. And then h naught, so it's h sub 0. That's how you say it, h naught. That's the object's initial height, so where I'm dropping it from. So here is our situation. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does it take the container to hit the ground? So we know it's dropped from a height of 50 feet, so that is our h naught. And we want it to hit the ground. So our final height that we're looking for is 0, and we want to know t. So here's our formula again. H equals negative 16 t squared plus h naught. So let's plug in what we know. So we know we want to find where the height is 0. So when it hits the ground, how long was it in the air? Plus h naught, which is 50. So now at this point we have the same type of problem that we had today in class. So we need to get the t squared by itself. So the first thing you want to do is subtract the 50. So the negative 50 equals negative 16 t squared. And then divide by the negative 16. And I'm just going to leave this right now as 50 over 16. And at this point, we're going to square root both sides. So remember, it's plus or minus the square root of 50 over 16. Now that can be reduced, but when we are using this in a word problem, if I reduce this to be, it would reduce to what? 5 square root 2 over 4. That doesn't really make sense for time. So we're going to just approximate this as t is approximately plus or minus 1.8. And we don't want the negative because, of course, we can't have negative amount of time. So 1.8 seconds. The container will fall for 1.8 seconds before it hits the ground.